So number one says slope field for a certain differential equation is shown above. Which of the following could be a specific solution to it? So really all you need to do is like if we drew a specific solution in here and it like followed along with these slopes. And remember, this is an infinite number of answers on the slope field, but if you drew in a specific one, it would kind of do something like that. And so all you have to do is pick which equation would follow this shape of a graph, and that would be Ln. Ln is this like sideways kind of swoop. So that one is E. And if you're like, that's it, yep, that's it. That's really all that there is to that. All right, 2 is matching. Which slope field goes with this differential equation, x over y? So what I usually tend to look for are the zero slopes or the undefined slopes, but those would be on the x and y axis, so it's really difficult to see them. So for this one, instead, I'm going to kind of look for slopes of like 1 and -1. I think that's going to be a little bit easier for this one. So if we're at point 1, 1, x is 1 and y is 1, we would have a slope of 1. 1 over 1 would be 1. And the same thing is going to happen if they're both -1. The negatives would cancel, and you would have a slope of +1. All right, now if one of them is negative, so if you have x is -1 and y is +1, then your slope is going to be negative. And same thing other way around. So, I'm writing all this out so that you can see this would be a -1 there. But I'm just looking for slopes of 1 and -1. Again, I usually look for 0 and undefined, but because those would be on the axes, it'd be really hard to see for this one. But the one this is going to match up with is E. If you look at like 1, 1, or even 2, 2, or 3, 3, do you see how you have all these slopes of 1 here? And then same down here. And then if you're in quadrants 2 or 4, they're going to be negative because one of them's negative. So that one is E. But again, you're essentially just matching the differential equation with the slope field. Oh, sorry, someone asked about, are you asking about C for number 1? That C wouldn't work for that. So your e to the x graph looks like this. And so if you reflect that over the y-axis, if you have e to the -x, that's going to look like this. So no, this would not fit with these slopes the way that that's reflected. So no, it could not be that one. All right, number 3, again, we're just matching this. Shown above is a slope field for which of the following differential equations? Again, I try to look for the 0 and the undefined slopes to kind of match these up. So I'm noticing right here, I have a whole column of slopes that are 0, and that's happening when x is -1. So when x is -1, all our slopes are 0. So what I'm going to do is just plug in x being -1, plug in -1 for x, and see which one of these ends up being 0. So for this one, if you put in -1 for x, you get -y, which is not 0. For this one, if you put in -1 for x, you would get -y minus y, which would be -2y, which is not 0. And for C, if you put in -1 for x, you would have -y plus y, which is 0. So that's the one that we want. Again, you can match up each individual point and go one by one if you want, but I think it's easiest to find the 0 or the undefined slopes. Or on the question on the other side of the paper, I found like slopes of 1 and -1, like focus on like one aspect, because if you try and look at every single point, this is just way too much. All right, number 4, the rate of change of the volume of water, so that's dV dt, that's a rate of change. So actually right off the bat, we can get rid of A and B for this, because those aren't even rates of change. That's just a equation for volume. Right, the rate of change of volume of water with respect to time, that's why it's dt, is directly proportional to, that just means there's going to be a k in there, you're scaling it by something, directly proportional to the square root of the volume. So that'd be square root of V. So that one is E. So you're just kind of interpreting like in words what they said there, putting it in math symbols is really all that was. All right, number 5 is another one where we're matching this up. Now this differential equation only has a y in it. So what that means is all the rows are going to be the same. And let me get another piece of paper and cover this up, because I know sometimes it's hard to see when you're looking at the whole thing. So if you look at letter A, See how this row is all the same, and then scoot this down. The next row is all the same, next row is all the same. So A is an option. If you look at, I guess this one's C, let me come over here. See how that row is not all the same? Those are all different. So it cannot be C. B, same thing. If you look at a row of that, they aren't all the same. So it cannot be that one. For D, same thing. That row is not all the same, so it's not going to be that. And E is an option. See how the rows are all the same there? Whatever row you're looking at, they're all identical. So we've narrowed it down to A and E. And then I would look at where the zero slopes are. Notice in A, we have zero slopes here and here. So that's happening at 1 and -1. If you plug in 1 or -1 for y, you're going to get 1 minus 1, which is 0. So you are going to have 0 slopes here at 1 and here at -1. So A is the one that matches up with that. For E, your 0 slopes are on 0. But if you plug in 0 for y, you're going to get -1, not 0. So that does not match up. And then 6 is a review question on limits. This says if limit as x approaches 3 of some function is 7, which has to be true? Well, not much. A limit really doesn't guarantee you a whole lot except behavior. Remember, a limit is just behavior. As we approach 3 on the x-axis, the graph will approach 7 on the y-axis. All the limit tells us is that both sides are coming to the same place. If you were to zoom in on this, both sides come to the same place. Are you having flashbacks back to September where like this was all we did for like several weeks? All right, both sides are coming to the same place. But you're not guaranteed continuity. There might not even be a point there. And if the function's not continuous, then it's not differentiable. So you're not guaranteed that either. And Roman numeral 3 says f of 3 equals 7. Well, no, you're not guaranteed a point there. Again, you're not guaranteed very much by a limit. The only thing you're guaranteed is that both sides come to the same place. So you're guaranteed that it doesn't do this. You're guaranteed that it doesn't do this. Both sides do not come to the same place here. So that's a guarantee. If you have a limit, you're guaranteed you don't have like a jump like that or an asymptote or something in there. Both sides come to the same place, but you're not guaranteed that there's a point or any of those other things. So that one is